Section 4.1 Basic Set Operations and Venn Diagrams. Definition of a subset. A set B is a subset of set A if all elements of B are also elements of A. We denote the relationship with this symbol. Sets A and B are equal if and only if they are subsets of each other. That is, B is a subset of A and A is a subset of B. A set B is a proper subset of set A if all elements of B are also elements of A, but A contains elements not in B. We denote the relationship with this symbol. The set that contains no elements is called the empty set, and we use this symbol for it. Example number 2. Use the sets A, B, and C to answer the following true or false questions. Explain your answer. Part A. F belongs to A. This is asking us if the element F is in the set A. Since, if you notice, F, it's right here, it's part of A, this statement is true. This statement is true because F is included in set A. Next example, part B. We have to check if K belongs to C. So let's look at the set C. We notice that the elements are A, E, I, O, U. So K does not belong to C. K is not included in set C. So this is a false statement. Since K is not included in set C, we have a false statement. Next example, part C. Let's check if B is a proper subset of set A. First, we check if all elements in set B are also in set A. So in set B, we have A, and it's also in set A. G, and we have G also here. E in set B, also in set A. H in set B, H in set A. L in set B, L in set A. So we check that. Now let's check if set A has other elements not in set B. And we notice it has a lot of them. B, C, F, I, J, and K. All these elements are not in set B. This means that B is a proper subset of set A. So this is a true statement. Since all elements in set B are in set A, and set A has other elements not in B, this is a true statement. Next example, part D. Is C a subset of A? So let's check if all the elements of C are also elements of A. I start with A. A is part of C. A is part of A. E. It's part of C. It's part of A. I is part of C. I is part of A. O. O, it's part of C, but it's not part of A. And the same for U. O and U are not part of A. That's the reason why C is not a subset of A. So this is a false statement. Not all elements of C are also in A. Next, we solve part E and F the same way as part D. Part E, let's check if all elements of D are also in B. The first element in D is L. L is also in B. Next we have G, also belongs to B. H, also in both sets. A belongs to D, and it's also part of B. And the last element in D is E, and E is also part of B. Since all elements of D are also in B, it means D is a subset of B. So part E, that statement is a true statement. For part F, we have to check to see if B is a subset of D. This is also true because if we notice, all the elements of B are also in D. So as we noticed earlier, if we look at the sets B and D, all the elements in B are also part of D. Part G. D and B are equal if and only if they are subsets of each other. We saw in parts E and F that indeed D and B are subsets of each other. It means that D equals B. So here we have a true statement. Part H. Is C equal to A? No, because as seen in part D, not all the elements of set C are also in set A.